Good morning guys. Para sa ating subject na logic design, prelim, okay? We have the first topic, number system. Okay, so whatever yung diniscuss ko last meeting, ulitin ko about number system. So numbers can be represented in different bases. A base of 10 is called a decimal. An example below, consider 356 or 356 in decimal. So if we write 356, okay, so we have the following format. Okay. So so this, mapapansin nyo, if we write them according to their format, we have the ones, the tens, and the hundreds. Okay? So makikita nyo reverse, no? Ones, tens, hundreds. Yung ones is represented by the 0 or exponent 0. The tens is represented by exponent 1. The hundreds is represented by the exponent 2 or the squared, no? So since naka-base 10 tayo, we will multiply the number by tens. Okay? So yung kanyang exponent is or will depend, no, dun sa kanyang position. For example, si 6 ay nakaposition sa ones. So ang kanyang imumultiply natin siya sa 10 with a 0 exponent. And then we will also have the 5 or the 50, which is ang position niya is nasa 10 siya. So we will have to multiply it by 10 with an exponent of 1. And also the 300, we will multiply by 10 with the square exponent. Okay? So ang square ng 10 is 100. So that's why we got 300. Exponent ng 10 ay ang equivalent ng 10 to the first power is 10 times 5 will give us 50. And the equivalent of 10 to the 0 power is 1 times 6. That's why we have the 6 in the first position or the ones position. So in general, a number can be represented in the form of, so ito na yung mga position niya, no? So si A is variable, so na-represent natin any number. So ang position ng bawat variable na yan is according to the number below. Ang tawag natin dyan ay index number. Okay? So index 0 is the position for ones, no? Like dun sa ating sample na 6. So we will have the following sequence, no? So ones, tens, hundreds, thousands. Okay? So yun yung kanyang mga position. And then itong may dot, that will be after the dot will be the numbers representing the decimals. So ito, pansin nyo, ang kanyang index number ay negative na kasi less than 0 na siya. Okay? So ang position nito is negative 1, negative 2, negative 3. The R is the base, no? So kung ikaw ay nasa decimal, I mean the binary, no? You will put 2 as the value of the R because R represents the base. Okay? So this is correct, but if you make it like this, it will be incorrect dahil wala namang sa base ng binary, wala namang number 2. Okay? So yung AI daw, so must be less than AR. So, ibig sabihin nung I represents the index number, kaya I, di ba? So, itong I na to represents any index number. So, ibig sabihin yan ay any A in any position, it should be less than the base. Okay? Example, kung 2, yan katulad yan, less than the base ba? Hindi, di ba? So, this is incorrect. Okay? So, kung 10 ang base mo, it should be yung highest AI mo is, highest index number mo should be 9. Okay? So, we'll use this following formula, no, to convert any number system to another number system. Okay? So example, convert 27.35 base 8. So anong base 8? Octal or octa to the base of 10. So paano nagko-convert? So ihahanay natin according to their position, no? So 27, si 7 ay nasa ones. So since 8, so we multiply 8 to the 0 power. Bakit naging 0 power? Kasi si 7 ay nasa position ng ones. Si 2 ay nasa tens, siya ay 20. So siya ay nasa tens. So multiply natin sa 8 times 8 to the first power. Okay? Etong decimal natin, we will also add, but it will be to the negative exponent, no? Negative power. So 3 times 8 to the negative 1. Bakit? Kasi siya yung nasa first position, and then second position si 5, so 8 to the negative 2 power. So if we will compute for this, we will it will give us 7 plus 16 plus 3.375, and the value will be 0.07825. Okay? And that will be equal to 23.45 base 10. Ibig sabihin, ito yung decimal equivalent ng 27.35. Okay? So if you will compute this, if you will add this for terms, for items, it will give you the decimal equivalent of the octal number. Okay? So second example, we convert the binary to decimal. Okay? So the same. So we have 11011, apat na 1, and then base 2. Equivalent niya sa decimal daw. So we will have to line them up according to their position, no? So 1 times 2 to the 0 power, ito yon. Next, we have the 1. Sorry, pabalik tayo, no? Pabalik. So ito yung 1 na to, ito yon. Okay? And then the 1, the next one will be this one. Kasi ito yung kanyang first position, no? So remember, ito lagi yung first position, ito yung last position. Okay? So after lining them up and multiplying the necessary, or doing the necessary operation, then it should give us the following 111 decimal conversion. Okay? Next, we have the converting from binary to decimal. Okay? So we will go back to our format, no? So the same, okay, but this will be for the base 2 or the binary number. So where A again represents any index number or any position. So ito is any 1 or 0 since tayo ay nasa binary, no? So equation 1.2 can be converted to decimal number by using this equation or this formula. Okay? Itong formula ito gagamitin natin sa pag-convert ng binary to decimal. Okay? So let's move on. Convert. Okay? this binary to decimal. So we will line them up and then do the necessary operation, and then it will give us 55.625. Or we can do an alternative option, but it's still the same, no? Yan. Gawa tayo ng table. Then, ipapasok natin dun yung ating mga binary digits, no? Okay. But it's the same operation. If a binary value is made of n bits of 1s, then its decimal value is 2 to the n minus 1. Okay? Kapag daw, katulad nito kasi may mga 0 to, no? Pero may shortcut kapag puro 1 lang yung i-convert mo. Okay? So, paano mo i-convert? For example, meron kang 6 na 1, walang 0. Okay, you will just use the following formula ito. So, kung ilan yung 1 mo, ilagay mo sa itaas ng 2, gawin mong power. So, 2 to the 6 power minus 1, it will give you the decimal equivalent. Okay? That is the shortcut. Okay? So, mas madali kung puro 1, no? Ang iyong binary na i-convert. Binary or base 2 numbers is represented by zeros and 1s. So, binary digit 0 or 1 is called a bit. 8 bits is called a byte, 16 bits is called a half word, and 4 bytes is called a word. Next, we have the converting, no, from digital or from decimal integer to binary. To convert an integer number from decimal to binary, divide the decimal number by the new base 2 for the binary, which will result in a quotient and a remainder, either 0 or 1. And the first remainder will be the least significant bit of the binary number. Continually divide the quotient by the new base while taking the remainders as each subsequent bit in the binary number until the quotient becomes 0. Yan. So let's take for example, convert 34, no, in decimal to binary. So we have decimal 34. Iko-convert natin sa binary. I-divide down natin. Okay? Saan? Sa 2. So, for example, 34 divided by 2. So, gagawa tayo ng table, no? Para malinis yung ating computation. So, we'll give us 17. Meron bang remainder? Wala. So, we put 0 here. And this is the first position. Okay? Yung tens. Next, yung quotient, yung result natin kanina, we will divide by 17. Will give us 8. Meron bang remainder? Yes, meron kasi si 17 hindi yan divisible by 2. So kung may remainder, we put 1 and that is the second position. Then yung 8, divide natin ulit sa 2, then it will give us 4. So obviously walang remainder. Then 4 divided by 2 will give us 2, then obviously walang remainder. And then 2 divided by 2 will give us 1, obviously walang remainder, so we put 0. And then 1 divided by 2, obviously we cannot, no? So we put 0. So yung pag quotient mo, yung result mo ay 0 na, then you stop. But still, maglalagay ka ng 1 kasi meron niyang point something, no? Pag dinivide mo. Okay? 0 point something. So kung may remainder siya, we put 1. So ito yung mga position niya, no? So when you write this, 34 is equal to 1. This the last position, no? The fifth, this one, yun, no? Pabaliktad kasi, di ba? So 1 0 0 0 0 1, yun yun, 1 0 0. So ito ang una mong isusulat. Remember yung ating formula sa taas, di ba? So 1 0 0 0 1 0 0 to the base 2 is the equivalent of the decimal 34. If a binary number is made of all ones, then by using the equation 2n minus 1, it can be converted to decimal. So, kung ang i-convert mo raw na decimal ay sa palagay mo, no, ay puro 1, okay? Then you will use, okay, the same formula, no, na diniscuss natin sa taas. So, binary number is represented by, yan, as we have shown sa ating example. So A5 yung first position, yung unang sinusulat natin, pabalik. Okay? So where A0 is 2 to the 0 and A1 is 2 to the first exponent until ma-reach natin si A5 which is represented by 2 to the 5th power. Okay? Next, we have converting decimal fraction to binary. So decimal number representation of point xy, for example, to the base 10 can be converted into base of 2 and represented by, yun, remember my decimal, yun, negative na ang kanilang index number. The fraction of numbers multiplied by 2. So kung ginawa natin kanina is division, since yung mga decimal number after ng dot is less than 0 na, negative ng kanyang index number, so we'll use the reverse operation ng division which is the multiplication. So the result of integer part 1 is a minus 1. So 30.35 decimal, i-multiply natin sa 2, then it will give us 0.7. Okay? So bakit 0? And then separate integer part from fraction. The integer part represents a minus 2. And this process continues until the fraction becomes 0. And then so ibig sabihin nito walang whole number sa unahan, so we put 0. Okay? So if we multiply 0.7 by 2 naman, it will give us 1.4. So meron siyang whole number, then we put 1, no? Then again, if we multiply 0.4, okay, remember hindi lahat, 0.4 lang, decimal lang ating minumultiply. So it will give us 0.8. So walang whole number, so meron tayong 0. Ibig sabihin whole number, walang carry over, so 0 ang lalagay natin. So multiply naman natin si decimal, 0.8 times 2, it will give us 1.6. So meron carry over, so we put 1. And then the 0.6 will be multiplied by 2 and then will give us 1.2. So meron carry over uli, so we put 1. Okay? Ano sabi rito? The process continues until the fraction becomes 0. Okay? So sometimes the fraction does not reach 0 and the number of bits used for the fraction depends on the accuracy that the user defines. Therefore, 0.35 equals 0.01, yun, 011. Okay. Welcome guys sa continuation ng ating number system for our prelim, first topic. So, previously diniscuss natin yung conversion ng fractions, no, into binary, no, decimal fractions into binary. Ngayon yung conversion ng decimal from binary to decimal, decimal to binary, we have a table, no. Ito yon, no. So 2n with different values of n, so we have the decimal value here for corresponding value of 2n, no. Yan, ito yung continuation, no? From 7, ito yung 8, 15, ito yung 16, no? So, for the 8 million decimal value, we have the 2 to the 23 power. Okay? So, we have also a table to convert decimal to binary or binary to decimal. Or also, we can use this table to convert binary to hexa and hexa to binary. Okay? So, we meron tayong table, no, sa pag-convert ng different decimal or number system. Okay? So the hexadecimal number system has a base of 16 and therefore has 16 symbols. So makikita nyo dito sa taas from 0 to F. So 0 to 9, A to F. Table 1.3 shows the decimal numbers, their binary values from 0 to 15 and their hexadecimal values. For example, si F ay ang binary equivalent niya ay 111 and decimal equivalent niya ay 15. Okay? So how do we convert hex to binary? So So table 1.3 can also be used to convert a number from hexadecimal to binary and from binary to hexadecimal. So we have an example 1.7. Convert the binary number, okay, this binary number to hexadecimal. So each 4 bits are grouped from right to left. So from right to left, we will group these bits. Okay, so we will have the following equivalent, no? So by using table 2.2, each 4-bit group can be converted to its hexadecimal. So after ma-convert mo to or ma-divide mo sa tiga-apat na bits na group, no? Then you will, so manonotice nyo kasi tiga-apat to, no? Para ma-convert mo si hexa into binary or binary to hexa. So if you will group this into 4 bits, then we can find the equivalent, correct equivalent, no? But it is also good to note na ang ating groupings ay from right to left, hindi left to right, no? So from our example, after grouping, no, the above binary number or binary bits, we can check, no, for the first group, the equivalent of the first group from our table above, and then we can see that it's equivalent to 2, no, for the hexa equivalent, no. The second group is equivalent to 9, and the third group is equivalent to A. So we have the binary above is equivalent to 29A hexa. Next example, we have convert 3D5 16 base 16 to binary by using table 2.2. The result is in binary is, so pabalik naman to, no, from hexa to binary. So we will check from the table 3, ito yung binary ng 3, and D, ito yung binary equivalent ng D, and then 5. Okay, so the resulting binary number is 001111010101. And also the following example, the same. Okay, we use the table to convert. Now convert decimal, binary, this binary to decimal. So again, we will use the formula or the the procedure that we use above. Okay, so we line them up, okay, according to their positions and multiply by the base of 2, and it will give us 55.625. We go now for the second topic for our prelim, which is the binary addition. Okay, so sa binary, pag nag-add tayo ng binary digits, for example 1 plus 0 equals 1, and 1 plus 1 equals 10. Okay, so bakit wala namang 2 sa binary? We only have 1 and zeros, no? So ito lang tatandaan nyo with regards sa operation ng binary digits, no? 1 plus 0 equals 1, 1 plus 1 equals 1, 0. So let's apply those principle, no, dito sa ating example. So 10101, i-add down natin sa 01101. Okay, so sabi natin 1 plus 1 equals 10. So 1 plus 1, 10. So we put 0 here and we carry over 1. Okay, so 0 plus 0 is 0, plus the carry over, then we put 1. Okay, so again, for the next digits, 1 plus 1, ito yon, 1 plus 1, then our answer is 10. So we put the 0 here, the last digit, and the first digit, which is 1, we carry over. And then this one, 0 plus 1 is, we say is 0, but we have a carry over of 1, so 1 plus 1 equals 1, 0 again. So we put 0 and we carry over 1. Okay, now for this, we have 1 plus 0 is 1, plus 1 again for the carry over equals 10. So we put 0 and 1. So the result, okay, for this operation is 10 100010. Okay? So ito lang ating dapat tandaan na principle. So in a binary number, the first bit from the left of the number is called the most significant bit. Ano yung most significant bit daw? Yung left of the number. So ito yon. And the first bit from the right of the number is called the least significant bit, which is the LSB, which is ito, the rightmost. Okay? So the most significant and the least significant. So, complement and 2's complement. The complement of 1 is 0 and the complement of 0 is 1. So, pag sinabing complement, kabaliktaran. Napag-aralan natin yan sa ating previous subjects, no? No, previous term. The complete of binary, the complement of binary number is calculated by complementing each bit of the number. The complement of 101101 is the inverse of this bit, no? So 010010. 2's complement of a number, complement of number plus 1. So kung ito daw yung complement, no, nito. Ito yung complement nito. Ang 2's complement of a number daw ay complement of a number plus 1. So ibig sabihin, pag sinabing ano yung 2's complement nito, ang sagot natin ay ito. Okay? Kasi dapat nating lagyan to ng 1. Okay? So pag nilagyan mo ta ng plus 1, it will be the 2's complement. Okay? Sample, find the 2's complement of 10000. So we will reverse, no? First, the complement. We will find first the complement niyan, which is this one, and we add the number to make it the 2's complement. Okay? So this one is equal to this. Subtraction of unsigned number using 2's complement. The following procedure is to subtract b equals, okay, we have the following position from a, which is a, with the following index number position. So add 2's complement of a and b, which is ito yon, and then check to see if the result produces a carry. So for example, we have 101010 and we have 11001 from a. Then we have the complement of b, which is 0101 plus 1. Ito yung inad natin na 1. Then it will be equivalent to 010110. So ano yung procedure kasi natin? Narito, if the result produces a carry, disregard the carry and the result is positive. If the result does not produce a carry, take the 2's complement of the result and the result is negative. Okay? So, ito, pag inad natin, anong result? Okay? So first, add 2's complement of A of B to A. So hanapin muna natin yung 2's complement na B. Paano hanapin? Kukunin muna natin yung complement ni B at mag-add tayo ng 1, which is ito yon, no? So binaliktad natin yung para mahanap yung complement. So yung 101010 ay naging 010101 plus 1. This will be the complement. Okay? And then we add 2's complement, which is ito, to A, no? Which we will find here. Okay? Yan, ito. So ito si B, remember? Yung nasa taas. Ito si A. So if we're going to solve this, okay? So okay, hindi lang siya nakatapat. So solve natin to. So 1 plus 0 is equal to 1. Ito yon. And then 0 plus 1 is 1. 1 plus 1 is 10 or 1, 0. So we put 0 here and then we put the carry over 1 there. So 0 plus 0 is 0 plus 1 yung carry over, then we put 1. And then 1 plus 1 is 1, 0. So we put 0 here, then we put the carry over. And then 1 plus 0 is 1 plus 1 is 0, 1. So we put 0, 1 here. Okay. So carry, you will notice we have a note here. No? Carry, discard the carry, and the result is 0, 0, 1, 0, 1, 1. So ibig sabihin nun is itong carry na to i-disregard natin. So what we have is a positive binary digits 0, 0, 1, 0, 1, 1. Okay? So the same with this. Negative siya. No? Subtract B. Ito yon from A. Ito. So we find first the complement, the complement and then the 2's complement. So ito yung complement niya, kabaliktaran ni B. And then we add 1 to get the 2's complement, which is this one. Okay? So after that, after this, we will add it to A, no? Which is this. So, katulad ng ginawa natin sa taas, so 1, 0, 1, nag-carry over tayo. So ito yung result niya, but as we can see, adding 6-bit number results in 6-bit answer. There is no carry, no? We just take the 2's complement of the result. Okay? So ito yung result, we take the 2's complement. Babaliktarin uli natin yung mga digits and then add 1 and then we put the negative. Okay? Unsigned, signed magnitude, and signed 2's complement binary number. Binary number can be represented in form unsigned number or signed number or signed 2's complement plus sign represented by 0 and negative sign represented by 1. No? So 0 represented by plus and negative represented by 1. Okay? So unsigned number, in an unsigned number, all bits of a number are used to represent the number, but in a signed number, the most significant bit of the number represents the sign. Ano yung significant bit? Yung nasa dulo, yung kauna-unahan. No? So yung most significant bit, yun ang ating MSB. So ito, i-note nyo rin to, all bits of the number are used to represent number sa unsigned. Okay? Sa unsigned yon. Okay? But sa signed daw, yung most significant bit or yung MSB ay ginagamit siya as sign nung number, no? So for example, sa unsigned, yung 1101 will give you an equivalent of 13, no, sa decimal. But kung siya ay signed, yung 1 na yon hindi siya nagre-represent ng number or ng any value, no? Siya ay signed. So in a signed number, the most significant bit represent the sign, which is where 1101 equals negative 5. 1, yung dulo 1 represented by negative. So ito ay itong binary na to ay negative 5. Kung naman siya ay 0, then it will be a positive 5. Okay? So in the unsigned number 1101, it will be 13 kasi unsigned siya. Pero kung signed number, then it will be either negative 5 or positive 5. Signed 2's complement, a signed 2's complement applies to a negative number. If the sign of the number is 1, then the number is represented by a signed 2's complement. Okay? So itong 1.16, 1.17, the same, an example sa taas, dealing with signed numbers, no? Signed and unsigned numbers. So I will not go over that. Let's go to binary addition using signed 2's complement. So the following examples show the results of the addition of two signed numbers plus 3 plus 4 represent both numbers in binary, and the most significant bit represents the sign. The result is positive. So yung 0, alam natin nasa unahan, since siya ay signed number, then it will be the sign, no? Yung positive. So this is 3 and this is 4, so we add then. The result is positive 7. So, if negative naman yung isa, okay? In sign to is 11, 0, 0 or 1, 1, 0, 0. Then, 1, 1, 1, 0, 1, 1 plus 1, 1, 0, 0 will equal to 1, 1, 1, 1. Result does not generate carry of then take 2's complement result, which is negative 1. So, hindi natin it-generate, no? So hindi nag-generate ng remember yung sa taas, 'di ba? Pag hindi nag-generate ng carry, then the 2's complement is negative, no? So this is negative 1. So, negative 3 plus 5, positive 5, equals 110 equals 110. So, ito yon, nag-generate ng carry. So, discard carry and the result is plus 2. So, remember again, sa taas, di ba? Kapag may carry, positive siya. Pag walang carry, yung 2's complements ay negative. Okay? So, this one would be the same. Okay? So, the same example, the same procedure and operation. Okay? Also, 1.18. You can go over that procedure para ma-practice nyo yung ating mga procedure, no? With regards to operation ng unsigned and signed binary numbers. Okay? We go now with addition of overflow. The following cases results overflow for adding two signed numbers. If ito daw nagre-result ng overflow with regards sa signed numbers, both numbers are negative and results of addition become positive. And both numbers are positive and results of addition become negative. Those are the condition under which the operation will produce an overflow. Okay? So basically that would be the coverage of our prelim, no? Sa ating subject na logic design. Okay? So see you guys sa next meeting natin.